Sorry about that. I meant to pause the recording, so we're up for a second recording. We're working on number 19, and this is section 4.4. And we have started to separate this quotient here. And now we can separate this product. So this is the log of x squared plus the log of y to the fifth minus the log base 10 of 10. And then this right here is really 10 to the x equals 10. So this is just a 1. So this is going to be minus 1. We can use our power properties to bring our 2 and our 5 out in the front. So we have 2 times the log of x plus 5 times the log of y, subtracting 1. 21, we have a natural log, and then we have this quotient. So let's go ahead and separate our quotient. So we have the natural log of the cubed root of x squared minus the natural log of e squared. Remember that the natural log and e are inverses of each other. So this is just minus 2 because that 2 will come down. Then we're going to rewrite this as a rational exponent of 2/3. And then that 2/3 can come out in front. So 2/3 times the natural log of x minus 2. I hope you're having fun. So let's look at 25. We're getting some little bit trickier ones as we go. So 21, we have this whole thing is to the rational exponent, and then we have a quotient inside there. So let's just split up the quotient at the time. So this is log a of x to the 6 halves because of the square root minus log a of y to the 3 halves and z to the 5 halves, because the square root is 1/2. So the square root of x to the 6 is the same as x to the 6 to the 1/2, which is x to the 6 halves. So that's how we can write each of these. Then I'm going to 6 halves is equal to 3. So I'm going to bring that power out in front. And then this is subtracting. And because there's a quotient inside here, I'm going to have to separate them. So we're going to distribute this subtraction in a minute. So this will be 3 halves log base a plus 5 halves log base of y plus 5 halves log base a of z. And the last thing is to distribute this negative. So this will be 3 log base a of x subtracting 3 halves log base a of y subtracting 5 halves log base a of z. They're getting longer. 29. So 29, the ones from now on, we're going to take the individual logs and put them back together. So we're going to go in the reverse of what we've just done. So because this is a subtraction, this is really a ratio of 6.3 over 3. And we can actually put that one into our calculator and say log of 6.3 divided by 3. And that comes out to be approximately 0.3222. which is also the log of 2.1 if you just divide those. So let's look at 31. So we have a plus and a plus, so that's really going to be the product of them all together. So it's 1 log of 3 times x times the square root of y. Okay, let's look at 33. So 33 is saying we have the natural log of 4 minus 1. And we want to put this together as one natural log. So to get to a 1, we would have to have the natural log of e. So this could be the natural log of 4 minus the natural log of e. And so, and because this is subtraction, it is really the quotient of the natural log of 4 divided by e. So we're going to have to use, whenever we see 1 with the natural log, we're going to have to think of it as this. So let's see what we've got here with 37. So 37 is wanting us to put this all back together. So this is going to be fun. We're going to take this 1/3 and put it back as an exponent of 8 and of 9. So this is going to be log 4, 8, the cubed root of 8, because that's a rational exponent, and then the cubed root of 9. Okay, so we're bringing this back together. So this is going to be the cubed root of x to the 9. And then minus log base 4x squared. And we can combine these because they're all log base 4. So that's the key, is they have to be the same base. So this cubed root of 8 is 2, and x to the 9 thirds is 3. So that's going to be x cubed minus log base 4x squared. So now we can take this and turn it back into the quotient of log base 4 of 2x cubed over x squared. And then we can simplify the x cubed over x squared into log base 4 of 2x. Number 41 is the next one that I'd like to look at. Okay, so we have a couple things going on here. This 1/2 applies to only what's in the brackets. So we have a quotient here because of the subtraction, and we're going to have a product here because of the plus. So this is really going to be the log of x squared minus 1 divided by x plus 1. And that is really the square root of these together because of the 1/2 power, plus log of x. So let's leave that for now. So this log of the square root, x squared minus 1, can be factored into x minus 1, x plus 1, x minus 1 over the x plus 1. So those will cancel. So we have log of the square root of x minus 1 times x, because of the plus turns into a product. And I'm going to bring the x out in front of that. So it's really the log of x times the square root of x minus 1. The last two problems that I want to look at have to do with the pH of a liquid. So if you go to the end of the lesson on page 367, it talks, well, actually 365, it talks about pH of a liquid, of a solution. The pH of a solution is a measure of the concentration of the hydrogen ions in the solution. So we talk about the pH of milk or the pH of orange juice. And it's given in units of moles per liter, where 1 mole is 6.02 times 10 to the 23 molecules. But we're going to find this pH is by taking the negative of the log of the amount of the molecules that you have, the moles per liter of whatever your hydrogen concentration is. So for instance, on A here, it says find the pH of solution A, where solution A is 10 to the negative 4. And so they're going to take the negative log of that 10 to the negative 4. And then that becomes a positive 4 times the log of 10, and that comes out to be 4. So the pH of that solution is 4. We can go in the opposite direction. If we look at C, it says we have something that has a pH of 9.2. What is the concentration of ions? So down here, we're going to let 9.2 equal the negative log. And then we're going to use that. We're going to translate that so that'll be the negative 9.2 of the positive log. And we know that the log is base 10. So it's 10 to the negative 9.2. And that comes out to be approximately 6.310 times 10 to the negative 10. So let's look at number 65 in the lesson here. The number 65 says, suppose solution A has a pH of 5. So we have one that has a pH of 5. And solution B has a pH of 9. And it says, what is the ratio of concentration of hydrogen ions of A to B? Okay, so we have to find the concentration of each. So the concentration of this one is going to be by taking, this will be 10 to the negative 5 for A. And then this one is going to be 10 to the negative 9 for B. So this is 10 to the negative 5. So we're going to do 10 to the negative 5 over 10 to the negative 9, which actually they flip because of the negative exponent. So it's really 10 to the 9 over 10 to the 5, which becomes 10 to the 4, which should really be 10,000 to 1 of A to B, because 10 to the 4th is 10,000. So that gave us practice taking a pH of 5 and finding the concentration. These are the concentrations of the hydrogen ions in each of those. And then the last one is, if we gave you the concentration of the hydrogen ions, 6 times 10 to the negative 8, what is the pH of that? So it's the pH is equal to the negative log of the concentration, which is 6 times 10 to the negative 8. And so we can just put that into our calculator, a negative log of 6 times 10 to the negative 8, which is 7.222. So catch me back for lesson 4 or 5, because we're going to actually use all of these properties to solve exponential and logarithm equations. It's going to be a lot of fun.